Hello everyone, it is time for another recitation. This time we're doing a bonus recitation on testing, and this will actually be the last of the recitations for Web 21, but this will not be the end of these videos. I would like to keep making them, and we'll see about the format going forward, so don't worry too much. For now, we're going to be taking a look at testing. And so we have a project here, and this is one of the projects I built in the earlier weeks. This is the WebDB 3 challenge, which was our project with pets and owners. So we have a database full of owners and then pets that belong to the owners, and pets can also have species. But we really only have some basic routers set up for the owners and the pets, and we're going to be testing some of those. In order to get our test set up, we're going to need to install some dependencies. So I'm going to do yarn add, or you would do npm install. I'm going to mark this as dev. Whenever we have dependencies that we need for our project, but we don't need for when the project actually runs, right? When our project is deployed, for example, on Heroku, what it will do is it will run this start script. Right? And that will invoke our index.js, and anything that we import or require or run in the course of performing this action, that is a regular dependency. Anything we use that isn't in here is a dev dependency. So nodemon, dev dependency. Heroku doesn't need that. And that will just cut down on the number of dependencies that Heroku needs to download and save for us. So I'm going to yarn add dev. We're going to install Jest, which is going to be our testing framework. We're going to install supertest, which is going to let us mock requests to our server. And that is it. I feel like I'm missing something, but we'll see. I can always add it in a second. Oh, yeah, cross env. Since I'm on Linux, setting environment variables isn't difficult, although there can be some issues when trying to set them cross-platform. So I'm going to yarn add dev cross env just to make sure we don't run into issues with that down the line.
Is that something you'd recommend for Windows?
Yes, for Windows I would. I think if you're using Git Bash, setting environment variables the basic way will work, but it can't hurt to have cross env just in case, because again, it's a dev dependency. It's not going to really matter for our production application, so you know, it's pretty much free as far as dependencies go. All right, so those are our dependencies, and we can see we have them in this dev dependencies section. If we accidentally install a normal dependency, you can remove it and install it as a dev dependency. And I believe just installing it again as a dev dependency will move it over. We also need to configure Jest so that it runs in an environment knowing that this is a Node program and not a React program. So I'm going to add this key called Jest, and its value is going to be an object with apparently slightly different indentation. It's going to contain a key called test environment, and its value is going to be Node. So this is just telling Jest that we're writing Node tests instead of React tests. And you could also do an npx jest init to get a big config file where you can change lots of other things. For now, this is really all I need, so that's fine to get me started. Then we're going to need to create our testing files. So we're going to take a look. Actually, I lied. We need to create our script to be a test runner, and I'm going to modify my indentation here because it's bothering me. I don't actually know what's causing it, so I'll just do this manually. We're going to create a new script called test, and this is going to run our tests. So this is going to be the command jest watch verbose, so we can see everything that's going on, and another setting that we will save for later. The thing we need to specify, though, is that we want to run these tests against a development database because we're going to be, against a testing database because we're going to be running code that's going to potentially modify the contents of that database. And it's also important for our tests to start off with a consistent, clean slate so we know the data that we're expecting. And our development database is not something we want in either case, where we could be unpredictably modifying it or, have different data starting up each time. So the way we're going to handle this is by setting an environment variable. And we can call this whatever we want. I'm going to call it dbenv, and I'm going to set the value to testing. And this is going to signal to my application that we want to change the database connection that we're using. And on Linux, this is a perfectly fine way to set environment variables. There may be some platform differences. In that case, we just have to add cross-env right here, and it will make sure this environment variable is properly set for us. And there we go. So now we need to write our testing database connection. So we're going to go into our next file, and right now we just have this connection for development, which is the one we're using by default. I'm going to copy and paste it, and instead make the key testing. And the only thing we need to change is this file name here. We don't want it to connect to the same file that contains our development database, so we're just going to rename this to test.db3. Everything else, our foreign key enforcement, the migrations, and seeds can stay the same. If you want, and we'll talk about this later, you could create a separate directory for testing seeds or migrations or whatever you wanted to do. So now that we have that connection, we're going to need to have our application connect to it while the tests are running. And the way we're going to do that is we're going to go into our data folder and our dbconfig, which for me is just db.js. And we need to change this up slightly, because right now Nex is connecting to the hard-coded development connection. And I want to, based on that environment variable, pick which connection that I want. So instead of using the dot syntax to access object properties, we're going to use the square bracket syntax, because that allows us to, put some code in here. So I want to use the value of process.env.dbenvironment, or if that's not set, I'll fall back to development so that I don't have to also set the environment variables for my development commands. And now, when we run our test command, crossenv is going to set this environment variable to testing, and that is going to use the testing connection inside of our next file. Any questions so far?
Yeah, so in your db.js, I'm sorry, that's your connects file actually at the bottom.
Yes.
You have development, and then you also have testing. Okay, that's the difference. I think I currently only have development.
Yep, I just copy and pasted development into testing, because the only setting we really need to change for now is the file name, just so they point to different files.
And so you want your seeds directory to be the only one that's different?
This under connection, we want this file name to be different.
Ah, okay.
Yeah, because we just want them to be different files. If you want, we'll get into later how to use seeds during testing. You can specify a different directory for seeds if you want, to have the seeds in testing be consistent, whereas you can freely change the seeds in dev or production.
Okay, and in your process, you have not yet created that test.db3.
No.
Okay.
Yeah, I have not. We're about to do that, though. So the way we're going to do that is we're going to come into our terminal, and we're going to create this database by migrating it. Now, you might be tempted to do something like dbenv is equal to testing, which is normally how we set environment variables, and then do npx next migrate latest. That's not how Nex works. If we want to specify the environment that we're using here, we could do --env equals testing. And now Nex will find that testing connection during migrations for us. And that's because when Nex runs this migration, it's not using our database connection file, right? That's something that we use inside of our JavaScript program. Here we're just invoking Nex, which is going to go find the testing thing out of our Nex file, and then run the migrations associated with it. So environment equals testing. And there we go. If we ls our data folder, we'll see that we now have the test db3 as well. I'm not going to seed it because we'll talk about that as we get into writing our tests. But seeding would be the same thing, env equals testing. All right, so now we have our testing connection set up, we have our testing database existing, and we can write some tests. So I'm going to write some tests for the owners router. So in the same directory as the ownersrouter.js, I'm going to create a file called ownersrouter.spec.js. It could also be .test.js. And then we're going to write some tests. So the first thing we need to do is require our server. And I'm going to do that, but I was lazy when I did this project, and I don't have a server.js. I just have an index.js at the root of this project. And this doesn't export the server. And so I might think, oh, well, I don't want to split this out into a separate file, so I'm just going to do module.exports is equal to server. And this will work the first time you run your tests. And that's because in the process of requiring this file will be executed, which will run this line of code, which starts our server up on a port. The second time we run our tests, it will execute this file, which will try to start up the server a second time, which will break because the port is already in use. So this is one of the reasons why we actually need that separate server.js file. And it's an easy fix. I am just going to grab all of this stuff related to setting up the server. And then I'm going to create a file called server.js, put it in there, and then export our server. Then inside of our index.js, I have to require the server. And we should be good to go. So then inside of my testing file, now I can import from server.js. So pop over here, and instead of importing from index.js, we'll grab the server. We also want to get supertest, which is one of the dev dependencies we installed, which is going to let us make requests against that server. And we can name the variable whatever we want. Right? This is like a named import in React. And also this is just straight up a constant variable. So I can call this whatever I want. Oh, did I spell require wrong? Also let me mute my Slack notifications. Yeah, I do that a lot. Thank you. Supertest is going to allow us to make these requests, so I might as well call it something more helpful like request. And that's also what it is in the training kit, so I'll stay consistent there. Now we can write our tests. So we can open up a describe block and we can say owners. And then in here we can define our various tests. So it get all owners, and we can make our requests in here. When I'm doing testing, I very much prefer to use async await as opposed to promises, because when I'm testing, generally my code looks a lot more procedural, right? I want to make the request, then do the next thing, then do the next thing, then do the next thing. I don't want to chain.thens. I might want to do multiple asynchronous things, and I don't want to have to bother with, promise.alls or nesting thens, and I also don't need catches, because if this test throws an error, that's good enough for me to know that this test failed. So I really like async await. So that's the syntax I'm going to be using. I did do a video earlier. It's a crash course into async await, but I think you'll find it's not all that complicated. What we simply do is we tag this function with the async keyword, and what that is going to make our function do is the function will immediately return a promise. And whenever we return from the function, or throw an error, or just get to the end of the function, which implicitly returns undefined, it will resolve that promise. And so we get async testing kind of for free because this will always return a promise, and the test will keep running until it hits the end or until we return or throw an error early. And now I'm going to make my request. So I'm going to make a request against our server. It's going to be a GET request, and I want to hit the owner's endpoint, /owners. Now notice again, I've required the server. We want to get the whole server. Even though we're testing stuff specific to this router, we don't import the router directly. One, the server is actually listening on a port, and we can make requests against it. You know, but also, like, we might apply middleware or do other things that change how our server functions outside of just the endpoints specific to the owner's router file. So I'm not testing those functions directly. I am testing the entire implementation of that router within the server, which is honestly better. Something I'll repeat a couple times that Dustin has said was our testing mantra, which is write some tests, not too many, mostly integration. If we can only choose to write a few tests, it's better to test larger parts of our application working together. So I'm not going to test the model functions here because they're very, very close in terms of implementation to my endpoints. The endpoints are really very shallow wrappers around those model functions. And so if I'm testing the endpoint and the endpoint works, I can be reasonably assured that the model functions are also working. If I test both, that's great, and now I know if the model function breaks versus the endpoint, but I'm still, if I only had one test, I would always rather test the endpoint, because that will give me coverage of both. And the error message might be a little bit harder to tangle out, but I'll never be in a situation where my model function works, but the endpoint breaks and I don't know. So, integration tests. And what I would do is, if this were promise-based, I would chain a .then on here, and I would do all my stuff in there. But with async await, I just have to tag any line that has a promise with await. And what that will do is it will execute this line of code, and it will stop. It will basically turn this into a synchronous line of code. And whatever value this promise, this request, eventually resolves to, that's what we'll get back. So I'm going to save this in a variable called response. And then I can check things about this response. So I'm going to expect the res.status to be 200. And that's going to be my test. So let's pop back to our terminal and let's run our tests. So we have a script called test, so I can just say yarn test. And there we go. Our test passed. Whenever we have a test that passes, we should always try to make it fail just to verify that it is doing something. All right. And that worked. So, do we have any questions here? All right. Let's keep going. One other thing is, if you look at the supertest library, you'll see it has its own chained methods that we can do to investigate parts of the response. Like we can chain these .expects and look at certain parts of it. And those are very valid and good to use. I just prefer not to, because sometimes I want to write slightly more complicated tests, and it's easier for me to just use the normal JavaScript tools I have rather than trying to conform to the supertest version, although they are very convenient for checking things like headers, because we can just specify the header name and then like a regular expression to match against that. So they are good for that, but I'm not going to be using them here. So here's our first test, and now I want to write a slightly more complicated test, because the idea behind this get is that it returns data. Right? It should return some data for me. Now, a slight inconsistency between supertest and between Axios is that we would expect from our Axios experience to find the response data underneath res.data. But when we console log this, I don't know where it ultimately showed up, but yeah, here it is. it's undefined. The data here is actually stored underneath res.body. And so the issue here is that this is an empty array. And I can check that. I can check that is what comes back, although this failed. Expact. And there we go. So we're now checking to see that the res.body is equal to an empty array, which is helpful, but not really. The whole purpose of this GET request, the thing that we want to test, is that it contains data. And that's the data that we're receiving back. But my testing database is empty. And so some of you might think, oh, I'll do something clever, which is I'll write another test just before this, which will add an owner. And so instead of sending a GET request, we'll send a POST request. And the way we add a body to a POST request is with the .send method. And we'll need a name. We'll choose me for now, and then we also need an email. And that will be under the email key. So now we can post a user, and this will run that test. And now we will see that when we expect the body in our GET request to equal an empty array, it doesn't. It now equals this object, right, that we had posted in. I'm sorry, this array with the object inside of it that we had posted in from our previous test. So now we can write these tests expecting data in it, which is all fine and dandy, except for the fact that having tests depend on the execution of other tests for its behavior is generally bad practice. Because what we're no longer testing here, we're actually no longer testing, if I were to change this to check and see if, you know, this array contained the object that we had just posted. I am actually no longer testing to see if this GET request works. And we just ran into another bug that I'll talk about in a second. We're now testing these two in conjunction, which in some ways is good, right? This is an integration test. We're making sure the round trip action works of posting to the database and then getting it. But if I wanted to do that, I should do that within a single test. What instead I have here is two both visually distinct tests that are logically tied together. And so what we want is in each one of these testing environments, we can make whatever modifications we want, but when the next test runs, that environment should be reset. And so when we were doing React testing, we used the before each with the clean helper that would reset the DOM to have nothing in it so we could then render the React application again. And there were times where I showed in one of my videos on testing that we actually wanted to carry some of that true, and we could disable it for a block of tests, and that's good. But generally, we want the order of the world to be in place before testing begins, especially because of this error. We tried to do another post request, and we got an error because of database constraints. Because we tried to post Henry with his email again, and the email has to be unique, and we never actually cleared out the previous Henry before we ran this test. And so now we're getting errors because our testing environment is not consistent. So we can do that with another before each. And we can write the cleaner function ourselves by importing our database connection. It's going to be data, db.js, and this is automatically going to pick up the testing database because of how we set the environment variable. And then I want to call db on the owners table, and I can truncate this table. So now when these tests run, before they're executed, we will truncate the table, and everything will be right in the world except yeah, so now this second test, excuse me, it's doing exactly what it's supposed to. It's failing. And that's because after this post test runs, and before our get request runs, we're going to clear out that database. So we're no longer expecting data there. And this may be frustrating because like how do I test there's data in here without posting it in? Well, I saw some of you have the workaround of manually, calling a DB on owners with an insert here. But wouldn't it be really, really, really nice if we already had a function that when we called it would insert data into our database, and when we called it, it might actually just clear out any existing data in the database too. Wouldn't that be wonderful? Well, we've already written that. That's our seed files, right? The seed files truncate our database in the correct order. Doing this, if we had other data in the database, might be disastrous. And then it seeds in a consistent set of data for us to use. And, as it turns out, Next actually exposes to us functions that we can call that will seed the database. So instead of truncating owners, what I'm actually going to do is call DB, and this is our next connection, right? You can look up in the next documentation for it. It's going to write this as next dot, but know that our DB is the same as that. Next dot seed dot run. And this will now seed our database before each test, which is also going to truncate any existing tables. So this post stuff will not carry into our get stuff. And we'll see these tests will rerun, and our second test will fail because now in our get request we are receiving the data from our seed. And I can go in there and I can copy and paste the correct data. I'm going to grab this out of here. Something you can do instead of putting this whole object in there is maybe we'll just check and see if the second thing from the body equals something. So let me get this formatted. So we'll do this and then delete that. And then we'll expect res.body.1 to equal this object here with Colonel Mustard stuff in it. And there we go. Now both our tests pass. We have a consistent state of our database, of our world between tests, but that state now also includes data. And that's very helpful when writing certain types of tests. So, do we have any questions at this point? All right. So then what I'm going to do is I'm going to do something that we would expect to be the next step, which is I'm going to test another router. Before I write any more tests for this, we'll assume we're good here. I want to test the pets router. So I'm going to go up into the pets directory, and then I am going to create a file called pets-router.spec.js. I copied some of this so I could be lazy about typing some of it. So we want to require super test. We want to require a database. Before every test, we want to seed our database. We're going to be testing pets, and we're going to be getting all of our pets here. So change this to a get request on pets. Don't send any data, and I'm just going to expect this to be successful. Let's check and see if this runs. So I'm going to save this file. And our test runner is going to pick this up, and boom, we immediately get this error. Error while executing the seed, delete from pets, SQLite, busy, database is locked. And that's because the way that SQLite works is only one process can actually modify the database at a time. There's a global database lock, so you can't insert a row into one table while inserting a row into another one, or rerun seeds and delete everything and take it out. And there is probably some clever way to make sure that our seed function waits until the database is unlocked before executing, but we can essentially do this manually with our test runner. That was not what I wanted. By going into our package.json and adding an argument to this test script, which is going to be -- run, capital I in, capital B band, run in band. And the reason this is going to fix our bug is because Jest will try to run our different test files simultaneously in order to make them work faster. Because again, with our testing thing, tests should not be dependent on each other's actions for their behavior to be correct. But when we have a database, they ultimately are. And even when we have databases that don't have global locks like Postgres, there'll still be table locks, and trying to delete and reseed everything before tests is going to cause issues unless we run these tests one after another sequentially. And that's what run in band is going to do. And so with that setting here, let's check our terminal and let's try to rerun our tests. So I know I'm popping back and forth here. So I'm just going to change this file, which is going to force our tests to rerun. Oh.
Hey, Henry.
Yes.
What was the reasoning for run and ban? Like, what was the error that you were getting?
I can scroll up to it. So it's this error. Database is locked. So SQLite will only allow, one modification of the database to happen at a time, and Jest will run our tests simultaneously. Not within a single test file, those would be sequential, but it will run multiple test files at one time. So we're actually trying to execute this seeding process twice at once. Once for the pets file and once for the owner's file. And when those happen at the same time, one of the two, in this case pets, is going to encounter that the database is locked, that it's already being modified by another process, and we're going to get this error. And there's probably some way to have the seed operation park until the database is unlocked. I don't know what it is. If someone knows, please tell me. But we can just add this run and band feature to Jest, which is going to have it, instead of running those files simultaneously, run every test sequentially. So we never have two tests trying to write to the database at the same time. So that was the error there. And we got another failure because I think I goofed something up in here where I'm not requiring the server. But I'm not sure what the second error is. We'll see if this goes away when we fix it. Okay. Async callback was not invoked within 5,000 milliseconds. Async callback. Huh. So I wonder why that post is failing. It's telling us that this is timing out, which it shouldn't be. But it does lead me to the next part of this discussion, which should fix this error. But I'm curious as to why this is actually timing out. So let me double check that I didn't do anything funny inside of that test file. Yeah, we're just sending this post request and waiting for this response, and we're not getting any errors. So for some reason that's taking a long time. But as we can see, the operations for each one of these tests, it takes a number of seconds. Get takes about 3 seconds. The post takes about 6 seconds. The get takes another set of seconds. And that's a long time, especially when we're writing lots and lots of tests. So something that we can do is, one, if we commit regularly, Jest will automatically, when we do this, watch, will only rerun tests whose files have been modified since the last commit. So that can cut down on it. But we would still like this to be faster. And one of the reasons why this is slow is because SQLite, after every operation that writes to the database, which includes truncation in our inserts, it has to save those changes to the file that our database is in. And that I/O operation, writing to disk, is slow. Thankfully, one of the very cool features of SQLite is that we can run the database entirely within memory. We don't actually have to write out our file to a disk. We can just use a copy of that database entirely within the RAM of our computer, which is way faster, at least with the current state of computer hardware. So what we do is we go into our next file, and we're going to change this file name under the connection. And instead of specifying a file we want to use, we give this a special string, which is : memory : and this will tell SQLite to, instead of connecting to a physical database file, to store the entire database in memory. And that's going to be significantly faster. But when I write this change and I rerun these tests, we're going to see some issues. So we change this file name to memory. Let's go and rerun our tests by modifying one of these files. Immediately, we're going to get some rejections here saying that our owners table and our pets table don't exist. And that's because they don't. We had manually migrated the database when it existed as a file on our computer for use in our tests. But we can't manually migrate a database that is ephemeral and lives in memory only so long as we're running tests. So we have to figure out a way to programmatically migrate the database before our tests run. Luckily, Next exposes functions that allow us to do that. So I'm going to modify our before each function. And it's possible that we don't need to actually migrate before each test. We could migrate before every test just to set it up within this test file. I'm going to keep it all here just because it makes it a little bit easier. And instead of doing db.seed.run, we're going to do db.migrate.rollback. And that's just going to make sure that our database has no existing migrations in it. Then, I don't care what that returned, I just care that it's done. I want to run db.migrate.latest. Then, when that is done, I want to run my seeds. And I have to return this. The before each functions work the same way as our asynchronous tests. If this returns a promise, Jess will wait for the promise to resolve before moving on. We could also write this in the async await style, or we could take in the done callback and execute that function whenever we're done doing stuff inside of here. But I'm just returning this promise chain. So now this is going to perform this action before each one of our tests, which is going to make sure that that memory database is both migrated and seeded. And this is going to go a lot faster. We also need to do this within the pets testing. So this is a good point in time to write this into its own helper file. So I'm going to go into the root of the project. I'm going to create a directory just called helpers for now. And I'm going to create, prep test db.js, and we will export this function. And we're going to need to import our database. And so now this will handle that. And we can just import this in our test runners. We don't need this database anymore now. So I'm going to comment that out. And instead, we are going to get our prep test db function out of helpers. And I need to save this file. And then we can just give this to before each. I don't have to write a callback thing because this is already a function. So I'm just going to use it directly. And we can do the same thing within our pets. So I'm going to pop over to there. And inside of here, we're going to require that, and then prep our DB before running. And so now we see all of our tests pass, and look, these all took less than a second to run, and the post didn't time out. So this was very quick using our in-memory database, even though we're actually migrating it before every test. But now we know, we might want to test some features that like delete database tables or something like that. I don't know. With this, we can be sure that the absolute state of the database is consistent. So, any questions with that? All right. I'm gonna show a little bit more setup stuff. So far we just have some very basic steps, but knowing how to set up your tests in ways that let you write basic tests is often the hard part. So with this project, I don't actually have any authentication set up, so I'm just gonna make some fake stuff, and I'm also gonna save this file so it stops yelling at me. So I'm gonna create a middleware folder. And I'm going to get rid of this one. And I'm going to create a file called restrict.js. And normally what we would do in here is we would require our JSON web token or our cookie session stuff in order to check and see if the user had a valid session. I'm just going to write a fake version of this where I'm going to check that rec.headers.authorization has our JSON web token in it, which that's our JSON web token, right? And so if it has this JSON web token, then we're going to call next. Otherwise, we're going to send back a 400. So this is going to be our restricted middleware. And for all intents and purposes, this is the same as a real one we would write. It requires some input in the authorization headers for the user to be allowed to hit the endpoint. And when we're testing, it would be a pain to do this. Right? So let's pop over to our pets endpoint. And I'm sorry, we're going to hit the actual router file. And let's import restrict. So we're going to get that out of our middleware, grab restrict, and I'm going to actually restrict this get operation so that only authenticated users can do this. And so let's check our terminal. We're going to see that this test now fails, right? Because we're getting this 400 back. We're not authenticated. And what we could do, if we had a working auth system, is we could log in and then grab that token and then get the pets, and that would work. And it honestly wouldn't be that bad in the async await style, because we can just await for the first request to finish. But the point is, we're no longer really testing the pets get endpoint. We're testing both the authentication and the pets test endpoint, which is good, right? That's a good integration test. It's covering multiple parts of our application. But we now have this problem, which is that every single restricted endpoint is going to require us to log in, get a token, and then send that through. And that's honestly not helpful to test more than once. If we can verify one time that our middleware works, then we're good to go. But having to do it every time is honestly just complicating our testing. And if that middleware ever breaks for some reason, we now have 7,000 failing tests instead of the one test labeled check that restrict middleware works. Right? So we're actually making our tests harder to read. So the solution to this is that Jest gives us the ability to mock both modules and our own JavaScript files. So we can write an implementation of our restrict middleware that we can run during testing, but still use the real version when our app is actually running. And the way that we do this is we go into the same folder as the file that we want to mock. So here I'm in middleware and I have restrict.js right here. I'm going to create a folder that's called dunder mocks, _mocks, _. Right next to the file that I want to mock, the file that I want to implement a fake version of. Then inside of that mocks folder, I'm going to create a file with the same name as what I want to mock. So I'm creating a file called restrict.js, and in here we're free to just define a different version of our function. So it's going to take rec and res and next, and guess what it's going to do? It's just always going to call next. And so we now have a mocked version of our restrict function that is always going to let us through. So we no longer have to be concerned about actually supplying the value within the headers. But we have to do a little legwork to get Jest to use this mocked version, because we're still using this real version inside of this actual endpoint. So we have to tell Jest to go out and do some magic and actually swap out this restrict function, this real restrict function, with our fake one. And the way we do that is we go into our test file and we require the real version of restrict, even though we don't actually use it here. Because what this is going to do is this is going to give Jest access to restrict in order to replace it with our fake function. So we require the real version of restrict. And then we call jest.mock. And again, we put in the path for the real version of restrict. Jest will know to go look inside of the mocks folder, so we don't have to do something like, we don't do that. We just put in the actual import path, the same one that we required here. And what Jest will do is it will, when that function is required, it will swap it out for the mocked version. So we have that going, and now let's check on our tests. I'll put it at the top now. We can see that they all passed, because we've now swapped out the implementation of our restricted middleware with one that's always going to pass. And I can remove this mock, and we can see that the GET request for the pets under the restricted endpoint fails, right? Because we're not actually authenticating. I can put the mock back in, and now this fake version of the function will work. All right. Any questions here? No questions on mocks?
I'm a little curious about the file for the mocks, or where you put the folder. What was that?
So we put the mocks folder at the same place as the file we want to mock. So I'm in middleware right now. I'm in middleware, which is where my restrict.js file is. I create a directory called _mocks, at the same level as the file that I want to mock. And then inside of the mocks directory, I create a file with the same name, restrict.js, and then I write the mock version of that function that I want to use.
I see. Thank you.
All right. So we can also do cool things with this mock, because we don't have to just define a normal function. If you all remember to the way back days of React testing, we used a thing called spies, which were special jest functions that allowed us to do things like see what arguments they were called with, or see the number of times that they were executed. We can declare our mock to be one of those. So we could, for example, while we're not actually testing to see if this restrict middleware works, we can check to make sure it's still being applied. We can check to see that it ran, which is a good thing to test, because we want to make sure that our middleware is in place. And we can write one test where we don't mock it, where we can make sure that that middleware is functioning. But we don't have to write more than one. But we should still probably test that it's there so we don't accidentally unrestrict certain endpoints. So the way we do this is we're going to define a mock function. And I actually don't know where in the jest docs it's actually helpful to see. The jest docs can be a little bit hard to read, so I'll just declare it myself, and you'll believe me that this is how we do it. So we invoke jest, and we don't have to require jest because when the test runner runs, jest will be in the namespace. .fn, which this is going to create our spy function. But we actually want to have an implementation for this function. So we say .mock implementation, and then we give it as an argument the function we want this jest spy to actually execute when it's run. So when I save this, all of our tests should pass, yep, as long as I spelled mock implementation correctly, because this is, essentially the same function. It's going to do the same thing here. But if I console log our restrict function, right, the one that appears normal, the one that we required within our testing file, we'll see that this is actually one of our jest spies. And we can roll up here, and we can see that this has got all of the cool mock methods on it. So for example, I could come into here and expect the restrict function to be called. And that passed. And now that this has been successful, I know that that restricted middleware has been applied to this endpoint. I don't know if it works, and that's really out of the scope of this test, but I do know that it's on there. And that's the important thing for our restricted endpoints in these tests. We would run into issues, for example. Let's say, let me actually take a look at this pets endpoint. I may need to pop into owners to do this. Yeah, so let's say getting a pet by ID for some reason is not supposed to be restricted, right? That's just the way that we have our code written. Well then, I would make the request to get the first pet, and I would expect the request to be successful, but I would expect restrict to not be called. We're going to see that this test fails. And that's because, we get a bunch of stuff in here because we said verbose, but that's because restrict was actually called in the previous request. And so I could move this before, right, this one is called, so that restrict has never been invoked, and then we do our get request, and that'll all work. But what we've ended up in is another situation where the state of the world matters between our tests, and it's inconsistent. The action of one test is going to affect the validity of another test, and that is not what we want. So instead, I'm going to move this back down, and we're going to use the same tool we have to reset the identity of the world, which is before each. We can have multiple before eaches, and what this is going to do is it's going to call restrict, which is our jest spy, our jest mock function, and we're going to call, what is it? I think it's reset. Here we go. Oh, no, it's clear. Mock.clear. And what this does is it resets all the information about this function being called. So I'm just going to clear this out. And so now we can test within each test whether or not this has been successful. And, oh, it's mock clear. I'm sorry. Not just clear. Mock clear. And now we'll find that both of these tests have been successful. And I no longer want to console log this because we're resetting the number of times it's been called in between our tests. Any questions with that? Alrighty. One other very cool thing with these mocks is that we can change its implementation at any point in time. So for example, let's say here, I actually do care about something in the headers, and I already have written the mocked implementation, and I don't want it to change, I just want it to change for this specific thing. Then what I can do is I can say restrict .mock implementation once. And I can give to this a function that will be used just for the next call here. So just inside this test, I can mock this function. And I can say, for example, console.log, I ran this test, and then call next. And this is obviously a bad example of what we would want to use this for. But we'll see just for this pets get test that we see this console log, and not for any of the other ones. So we can on the fly mock this implementation. So a good use case for this, for example, would be some of you in your build weeks so far, you have endpoints that the content changes based on the user making the request. And you grab information out of their token in order to determine who the user making the request is. But we're not sending a token here. And rather than logging in, getting a real token, sending that out here, I could just do something like rec.user is equal to, ID of 1 in here. So I can essentially mock the successful decrypting of our token and assigning of data here. So that would be one way to write a slightly more complicated mock. And this is also something that we could do within our main mock implementation, but we might want to test, different users for different cases, or, see what happens when we don't include it. Does the application fail gracefully, or does it just fail? You can write tests that you expect to fail, and that's actually good, because then you'll know once you've fixed them. So, yeah. All right. Any questions here?
Yeah, sorry, that restrict mock implementation once, that's a special mock function that's overriding the other one that's in the before each, right?
Yes. We have
Okay.
this mock implementation once, which is defined for our just spy functions, which lets us, just for one invocation of the function, determine how it's going to work.
I see. Thank you.
You're welcome. All right. So that about covers the setup portion of this. We set up our testing database. We can make it an in-memory database if we want our tests to be faster. We can prep our database before each test by migrating and seeding it so we have consistent data within our database. And then we can also mock parts of our code that are hard to test, or that we only want to test once and then all other times assume that it works correctly. Those are kind of the big steps within testing to make it easy to write short, simple tests. And this is really what most of your tests should look like. Make the request, check the status code, make the request in a way that we expect it to fail. Right? So I would get this ID, and then I would want to try to get some pet that doesn't exist. And I would expect this to 404. So it's good to have both tests of the positive case and the negative case. And that's it. Check your status codes, try to make it fail, try to make it succeed. If you have a GET request and you have seeded data, you can always check that the return data is the same as your seeded data. If you have, a big GET request returning lots of things, like in the case of our owners. You can check and make sure that it equals the big thing, or you can just check some subsection of that data, which is not an exhaustive test, but in many cases it can be good enough, to verify that it's working. Yeah, so that is testing. Any questions here or specific things you would like to see within testing your endpoints?
So question, are you setting up different testing files, or are you writing this all in one file?
Oh, so these are in different files. It's generally a good idea, to write one testing file per router.
Okay.
So here is my owners directory, and in here I have my owners router, and then the owners router.spec.js. In this
Okay,
file,
that's what I thought. I just wanted
yeah.
to make sure I wasn't missing
Okay.
something.
Yeah. And I know it's a bit hard to read, but at the bottom of every one of the little windows that contains a file, it does contain the path to that file in there.
Okay, awesome. Thank you.
Yeah. All right. Any other questions? Things we'd like to see? Okay. Well, if no one has anything, that's most of the stuff that I wanted to show. Because really you'll just be waiting for this response and then using our basic tools to test and see if its content is what you'd like it to be. Test good and bad reactions, which good and bad is a misnomer. Successful and unsuccessful operations, because the API should be unsuccessful in some cases. You can seed the database beforehand. You can migrate the database beforehand. You can use an in-memory database for faster execution. And you can also run the tests sequentially to avoid database locking issues with the run and ban flag.
And would you basically recommend just testing all the models or some subset of them?
If you had to pick, I would only test the routers, because that's that mantra of write some tests, not too many, mostly integration. The key behind that is they're actually intertwined, because the more tests we write, the better code coverage we have. But what happens if I want to change the implementation in a way that is correct, but no longer matches the tests? So let's say I actually have the owner return another piece of information here. Well, now I have to go change all of my tests to match. And if I'm testing both the model and both the endpoint that returns the data from the model, I now have to change two tests. And if we have too many tests, which you absolutely can have, doing any positive change results in a lot of time spent updating tests, and that taxes your job as a developer. So we don't want to write too many. Well, how do we not write too many? We can do mostly integration tests, right? If we have to pick between one, testing this get endpoint will also implicitly perform a test on the model. And in some ways it's not as good, because this endpoint can fail and the model can be the cause, and I won't always immediately know from it failing that the model did it. Whereas if I had a test on the model, then I would know right away. But if I had to pick one, it's good enough, because I'll figure out it's the model pretty quickly, and if there's something else in there causing it to fail, I get that too. So if you're testing models, I would say don't test ones that are super simple. If you have a really complicated model function, go ahead and write a test directly on that, but test all your endpoints first. It's more important to test the things the users are going to interact with, right, or integration test, versus implementation details, even though oftentimes it's easier to write unit tests on the implementation details. Although working with databases, right, this external store of state makes testing generally hard.
Awesome. Thank you.
You're welcome.
Hey, Henry, I had a question. I don't think I was here when you, or if you showed the command to have your tests look at your testing database.
Yes. So the way we do that is we have to set up in our next file another database connection. And let me make this bigger. So previously we had development. Now we have testing. And this is going to be entirely the same except for the file name. And we could change this to be like data/test.db3, and that'll use a different database file physically. Or we can have it be this special string :memory:, which will tell SQLite to not actually save the database to a file, and instead use a version entirely within memory, which is going to be much faster, and is also going to disappear at the end of our testing, which is good. We don't really want it to stick around.
So with that memory file name, you don't even need to run the special connects or whatever. I can't remember what the command was.
Yeah. So
sure
to
it's
run
pointing
that
to the
command
test
with
document.
next, it would be npx next migrate latest, and then we'd specify the environment we would want this to run with, which would be testing. When we have it in memory, we can't do this. I mean, we can, and it'll be successful, but as soon as this command stops, that database ceases to exist. So what we do is we use a special before each function, which before each one of our tests is going to prepare the database for us. And I just wrote it out in a separate helper file that we can take a look at. And what this does is it actually uses our database connection to run the migrations. We can do this from within JavaScript. So we're going to we're going to roll back the database migrations, just make sure there's nothing in there. Then we'll migrate, then we'll seed. So before every test is run, the database is in the ideal, perfect state, consistent across all tests. And this also avoids us having to run this before every time we test if something gets gunked up or something like that. It's just going to happen when we start doing our tests.
So with that memory file name, do you need to set up an environment variable?
Yep. We would still need to tell our database connection here that we're requiring that we want to use the testing version rather than the production or development versions. And so in our db config, which for me is just db.js, we pick the next config using the process.env in the environment variable I called db-env. I have this OR in here as well, so it will default to development in the case that it is not set. And then within our package.json, the script that we use to run our tests does contain that environment variable being set to testing. And here we're using cross-env to make sure this works across all platforms.
Thanks for showing me that memory file name. That's cool.
Yeah, when I did my backend, I had, something like 30, 40 tests, and even with that small a number, it was starting to get slow. So the memory helps. Memory makes it really fast. All right, cool. Any other questions?
Yeah, the db-env, that's foobar, but I've been using node_env.
Yeah.
I thought that was how Heroku knew that I was in production.
I do not believe Heroku sets node-env by default. It may, which is why Luis would have used that. But it is foobar. We can call this whatever we want. The use case for having separate environment variables here is if we wanted to turn on some type of production behavior but still use a testing database, for example.
I see.
So we could have like a staging database that we would want our program to be in production mode, and I don't know what that entirely would entail besides changing the database connection. Usually things like changing the way we do some type of logging or something like that. And would want to separately set the database environment to some Postgres connection that isn't the deployed production version, but some, testing Postgres database. So
That makes sense. I see. So then on Heroku, if you were using this dbenv and you wanted it to switch over to production, you would just set that in your config varies.
Exactly. Yes. All right. Any other questions? Okay, cool. Well, thank you all so much for stopping by. It has been my absolute pleasure to run these recitations and to have you all here. So I appreciate it greatly that you all show up and ask great questions. And this will not be the end of these videos. I'll find a way to keep it going, and I'll keep you posted on that. So thank you, everyone, and I'll see you later.